All right, so as before, I'm going to speed through this, assuming that you've watched the first video for problem number 10, which really laid it out in detail, and then hopefully you've watched the other videos as well, so you're really getting a hang of it. I'm going to stop the video. I'm going to plot these points and connect them and come back to you in a moment to discuss. Okay, so here's our figure, and what I'm going to do right now is just straight away, I'm going to draw these lines that we're going to use to mark what the slope is and what the distance or length is. Whoops, a little bit too wide. And so of course I'm not writing the values in. We got to calculate those. And I'm going to just start by doing um, the slopes. Let's do the slopes first because that's pretty easy. We rise 3, run 1. Rise 3, run 1. 3 over 1 slope. Slope of 3. Okay, and we'll just do the same thing here. Rise 1, run 3. 1 over 3. So slope of 1 over 3. Down here, going all the way around. Rise 3, run 1. Slope of 3. And here, rise 1, run 3, slope of 1/3. Great. Okay. And of course, we need to do the distance. We need to calculate the distance, which really is like c squared equals a squared plus b squared, or as you know from the other videos, c equals a squared plus b squared, and then square root the whole thing. So what are we looking at? Let's do the first one, and then you're going to see something that really speeds this up. If we sketch this out, we're really talking about a triangle that, let me draw the triangle in green this time. I got a lot of yellow going on to make or let's use blue. Right here we've got a 1 by 3 triangle. I can do a little better. A 1 by 3 triangle, okay, like that, right triangle. So we've got 1 squared plus 3 squared. And that results in a square root of 1 plus 9 or square root of 10. And as we talked about before, this breaks down into, if we broke that down, it's just 2 times 5. There's nothing in there twice that would allow us to pull it out front. So we're just dealing with a length of root 10. And of course, here it appears in our formula over here as c because that's a modification of the Pythagorean theorem. But we're using d when we record it because d is, when we say d, what we mean is distance. So we've got a distance of square root of 10. Okay, before I erase this, we got the slopes already. I'm going to erase this triangle, but note this. When we figure out what this shape of the other triangles are, let me actually sketch them all in blue, and you'll see something interesting going on. That one, I'll leave this first one. That was 1 by 3, or 3 by 1 rather. This is 1 by 3. This is 3 by 1. And this is 1 by 3. All of those have one side being 1, and you can see that 1 in the formula here, and then one side being 3 here. So they're all going to result in square root of 10. Neat. What does that mean? Well, what that means for us is they all have the exact same length, root 10, root 10, root 10. And you can see why, yeah, we can do the distance formula, but I'm really doing you a favor by not requiring that and just allowing you to do these calculations as Pythagorean theorem type of figure out what the two side lengths are if you were going to make a right triangle and use that side as the hypotenuse. Because then instead of doing it over and over and over for different coordinates, you can see how we can apply this and say, aha, look at that. We're getting that same 1 by 3 triangle, 1 by 3, 3 by 1, and 1 by 3, same thing. They're just a rotated triangle, and therefore we're going to get the same length. So we have all sides being the same length. We know that it is what? All sides the same length means that it is a rhombus. And what do we know about the slopes? We have a slope of 3 here and here, and we have a slope of 1/3. It seems like they have a relationship, right? Right, it does seem like that. Here's the problem. That the only way that it's meaningful is either if we have the exact same slope, like we do on the opposite sides, 3 and 3, that means they're parallel. Or we have opposite reciprocal slopes, meaning if one of the slopes was 3, I'm going to write this down here in green so you can imagine it. If one of the slopes is 3, then the other one can't just be 1/3. It's got to be -1/3. Then, if we get that, we have opposite reciprocal slopes, and we know that the sides are perpendicular, forming 90-degree angles. And if that was the case, then we could deal with that and say that's either going to be a rectangle or a square, in this case, because the side lengths are the same. But that's not what we have. We just have 3 and 1/3. And although they're reciprocals of each other, that is one of those red herring type of be careful, that's not actually a thing. 3 and 1/3 together aren't a meaningful pair of slopes. In what we're looking for, it's either a negative reciprocal, it's exactly the same, or it's just two lines that just happen to have numbers that seem like they go together but don't. So we know that we have all 4 side lengths, and that's good for us. That means that we have a rhombus, but nothing about their slopes is helpful to categorize it any further than that. So what we have then, and let me write it in here, is we have a rhombus. That's the problem. Hopefully you're getting the hang of it.